All right, you guys, we're starting chapter 9 today. So here is what my plan is and my vision is for you guys as you're watching this video. First of all, I'm not trying to make some long ass video, okay? So if I go too fast, you can pause and you can rewind, all right? I do have everything already filled out. So what I would suggest is pausing the video, filling out the stuff, and then playing it so you can hear my explanation, okay? You need to listen, but I know you can't do that very well while writing at the same time feverishly, okay? So all of these vocab words, I am super excited. These vocab words that you have written down and filled out into your reading guide are words that we are going to use on a daily basis starting today forever until the AP exam is over, okay? These vocab words are critical to your success in chapter 9, chapter 10, chapter 11, chapter 12, okay? And I'm going to talk about a lot of them today in this video. So what I'm going to do is introduce some of the important stuff. I'm going to talk to you about how to write a null and an alternate hypothesis. I'm going to talk to you about a p-value, what it means, what it tells us, and the interpretation for it. And we're going to talk a little bit about drawing some sketches as well and trying to answer some questions about significance tests. This is the title of this chapter. Again, I would suggest pausing the video, copying down, and then listening to me talk, okay? What we are doing here, second semester stats, is about inference. Inference is when you make a conclusion or a determination about a population, okay? In chapter 8, what we did was this, confidence intervals. And we estimated a number that we didn't know. And remember when we played trivia and we're like, oh, I think the answer is between this number and this number? That is what we did with estimations for confidence intervals, okay? We did that in chapter 8 and you guys crushed it, okay? Now, chapter 9 is titled significance tests. What is that? It also helps us determine stuff about a population, but key words here, we are testing a claim, not making an estimation, okay? The difference between this word and these words will help you get multiple choice questions right, okay? Hint, hint. And there's a lot of like acronyms and symbols and stuff that we're going to talk about as well. So what I'm going to do here is I'm going to go into question number 1. You can see I already have it filled out, and I'm going to read through the scenario, and I'm going to talk about all these things that I have circled and arrows drawn to and stuff, okay? According to the U.S. Centers for Disease Control and Prevention, we have a number here, an assumption that we are assuming to be true. They say, they claim, they think, they believe, and we have a percentage here. 22.1% of high school students get at least 8 hours of sleep per night, blah, 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 regarding sleep, okay? A school counselor thinks, worries, wonders, is trying to decide. You can see like the wording, how it's leading us to believe that we're not sure about this 22.1, this assumption that I have already written here as my H sub 0. I'll talk about that in a second. She thinks or he thinks that fewer than 22.1% might be the answer for students at their school. I'm in favor of this as well. I believe you guys are getting way less than 8 hours. But anyways, to investigate, a counselor surveys a random sample of X number of students. In this case, it's 50, and only 9 of them have responded that they slept 8 hours. Okay, let's define the parameter of interest. What is it that we are interested in? And that is the proportion of all U.S. high school students who sleep 8 hours at night. And we have a number that goes with that in this case. Remember last chapter we were trying to like estimate this number and we didn't know what it is, so we did our confidence interval. Now we have a number for it, we have an assumption, and we're going to test it. Okay? The statistic, not to be confused with the parameter, is the p-hat. We took one sample of 50 students and we got whatever 9 out of 50 is, 18%. Okay, if we take a different sample, we would have a different p-hat. You remember this? And it would probably not be 18%. It would probably be something else. And just because we have this assumption, 22.1, does not mean every single time we take a sample, we're going to get an answer very close to it, right? We might get really close to it. We might get really far away, but every different p-hat is going to be a different value. Okay? And so now we have these things that you wrote in your reading guide. We call the H sub 0 or the H naught. This is the null hypothesis. This is what we are assuming to be true. Notice I wrote it right here, right after I read it. Okay, the H sub 0, H naught, the null hypothesis, that's a vocab word, is whatever we're assuming to be true. And notice I'm not using a p-hat right here. The p hat is the sample. That's a different number. The assumption, what we're assuming to be true, is the p about the entire population. So this is a regular p, okay? And yes, the null hypothesis, you should have read about this, is always an equal sign, okay? How do we write the alternate? You have to read the wording of the question. The counselor worries that the number is less than 22.1. See how I wrote a less than symbol there? Why did I do a less than symbol? It comes from the wording of the question. This says fewer than 22.1. That is my alternate hypothesis, H sub A. Okay, that's a vocab word as well. Because this is pointing in one direction, that is called a one-sided test. I will come back to that after we do example number 2, okay? So we have some vocab words. We have parameter. I think you should have already known what that word is. We have a statistic with a sample symbol that goes with it. You already know what that word is. We have a new vocab word, a null hypothesis and an alternate hypothesis, okay? Yes, for the null hypothesis, we always write an equation. And for the alternate, we find out what the wording of the question leads us to put there, okay? Let's look at letter 1B because this is an extremely important vocab word, p-value. You wrote that down in your reading guide, and the p-value is 0.2424. Interpret this value in context. Okay, don't go crazy with copying this down and then don't listen to me, okay? I need you to hear this. What does the p-value tell us? So notice that I drew a little normal curve here, and yes, normal is one of the conditions we're going to be testing for. Okay, but notice that I put my null hypothesis number, the assumption, the number that we were told or assuming to be true. That's the number that we center our bell curve on, okay? We don't center it on the p hat because you know every time we take a p hat, we're probably going to get a different value, right? But the assumption, the null hypothesis number, is the number that you center your bell curve on. And I'm going to draw a line at my statistic, which is 18%, which is right here. And then I'm going to shade this direction because it matches this symbol right here to the left, less than, fewer than. That's why I'm coloring this direction. And the p-value is a probability, okay? This shaded area right here is 0.2424. And how do we interpret this value? How did I calculate this? We'll learn how to calculate it next section. You're going to read about it tonight. Right now, we're just told that number, okay? Yes, we are going to learn how to calculate these values. Interpret the value in context. So again, you wrote this in your reading guide too, the interpretation of the p-value. You start with assuming the null hypothesis is true. We assumed this number went right in the middle, okay? As you know, whenever you take a sample, we're expecting the sample statistic to fall somewhere like close to this, right? We're not expecting it to be 0.221 every time, but like we're not expecting it to be super far away either because we're assuming this number is true. So we got a sample statistic that's 18% or 0.18. And so this number is actually not that far away from our assumption based on this shaded area right here. It's like not that far. Therefore, I'm not considering it uncommon. Do you remember the conversation we've had starting back in first semester that in stats we have kind of a rule of thumb and we usually use 5% or less to consider something uncommon or unlikely or unusual? This is 24%. That is not that uncommon because what that tells us is this 18 is not that unusually far away from 0.221. Okay, so you can write down like the interpretation here, including like the wording with the 50 students and getting less than 8 hours of sleep at night, whatever. But we are assuming the null hypothesis is true, assuming the 22.1 that we were told is the true center of that bell curve. There's about a 24% chance, probability, that we are going to take a sample of 50 students and get a statistic of 18 or less. See where I shaded here? Or less. I'm interpreting this shaded area to get less than 8 hours of sleep at night. 24% is not that uncommon, therefore I do not have evidence to like refute this number. I would say to the counselor, no, we don't really have evidence that this number is incorrect based on the sample you took. We'll talk more about that, but remember that it is an interpretation of the shaded area. Let's try another one. A change is made that should improve student satisfaction with the parking situation. I wonder how many of you guys have a parking pass and are you satisfied with the availability of the parking pass? Okay, so before they decide to change the rules or whatever, 37% of students approve of the parking that's provided. There is my null hypothesis. We have an assumption before the change. We have like a baseline or whatever. This 37 is a P. It's not a P hat. This is the P hat. And we take a sample of 100 students, and the dean claims that a lot more of them are now unhappy with the parking situation, okay? That is our P hat, our statistic, okay? I'm going to define the parameter in the statistic just like the directions tell us to. The parameter is the proportion of all students at this school who approve of the parking, and we have a number for that, 37%. That is the parameter. I'm using a regular P, and that is my null hypothesis. And yes, the null hypothesis, just like this one, always has an equal sign. My statistic from the one sample of 100 students that I took yielded a percentage of 48%. If I took a different sample, I'd probably get a different number than 48, but the one sample I took gave me 48. Okay, the change is made that should improve. Do you see that key word right there? We are hoping that the percentage gets higher than 37%. Okay, 37% approve of them, and we have a statistic that says 48% approve of them, and we are trying to increase the number from 37 higher. So we're trying to improve the situation, hence I have a greater than symbol in my alternate hypothesis. Okay. This is a one-sided test also because I'm shading in one direction, and you read something about a two-sided test and filled something out on your reading guide. I'll get to that in example 3. How do I interpret this one? So I'm going to again sketch my bell curve right here, and remember the null hypothesis, the assumption, the baseline is the number that goes right in the middle, the 37. We took a sample and we got 48%. So that's over here. I'm going to draw my line and I'm going to shade, and they're telling me that the p-value for this one is actually a very small number. Okay, because this small number is so tiny out here, it represents such a small shaded area, that tells me that this 48 is actually pretty far away from our assumption. The distance there is actually quite far. This distance here, not very far. This distance here, very far. How do I know that? Because look, this is 24% shaded area. That's not considered unusual in stats. This right here is such a tiny little area, less than 5%. It's 1%-ish. That tells me that this number is unusually far away from our assumption. That makes me question this assumption. Okay, assuming the null hypothesis is true, that's exactly what we wrote up here. There is about a blank percent, this number, probability that a sample of 100 students would yield 48%. Why did I put or more? Because I'm shading to the right. It's a greater than symbol. This is considered unlikely. Therefore, we have evidence to support this. Okay, we're going to talk about rejecting and failing to reject also. Okay, we'll get to that after I go through these 3 examples. The point is that the 0.48 is so far from the original assumption, so it is unusual, surprising, interesting. I think that this number is no longer the center. I think we actually have improved student satisfaction. Okay, let's talk about number 3. Grapefruit juice, as you know, there's like human error and machine error, and not always does every single bottle of grapefruit juice end up with exactly 180 milliliters of liquid in it, okay? And so quality control inspector is trying to check to make sure the machine's working properly. We take a sample of 100 bottles, and we have a sample statistic of this number with a sample standard deviation of this number. Okay, so what are we going to do? I'm going to define the parameter. It's the average amount of juice in all the boxes. And notice how I've done like P's up here. These were percentage numbers. Now we're doing like a means question. Yes, our textbook does separate proportions and means in this chapter as well. So notice how these numbers that we're analyzing here are not proportions. They are like whole number values. So that's why I'm using mu, which represents the parameter from the entire population. I took a statistic, note the symbol, and I got 179.6. Okay, I wonder, like, that seems pretty freaking close to 180, right? Here's our standard deviation. Let's talk about the p-value when we get to it. I have a null hypothesis. Note I'm not using a P here because this is a means question, and I am assuming that the company's like baseline or whatever they're trying to fill all these bottles up is true. And the alternate hypothesis, this is interesting, it just says working properly. I have no inclination based on the wording of the question whether I want to use a greater than sign or a less than sign. If you aren't sure, use this. If the wording of the question does not say greater than or less than or fewer or more or any key word like that, all this says is working properly. It could be underfilling, they could be overfilling, we don't know. I am going to use this symbol in my alternate hypothesis, and it is going to be considered a two-sided test. These are both one-sided because I shaded one direction. This is a less than symbol, I shaded left. This is a greater than symbol, I shaded right. This one said fewer, that's why I did left and less. This one said improve, that's why I did greater than and right. This one doesn't tell me how to shade, so I have to use not equal. I did get a sample statistic of 179.6. That's the X bar from that one sample of 100 bottles I took. I'm going to draw my line right there, and I'm going to shade this direction. And I'm also going to, because it didn't say less than or greater than or less than, I am going to reflect this number over here. The difference here is what, 0.4? So I'm going to go 0.4 this direction as well, and this gives me my other tail. In a two-sided test, we have to look at both tails. Okay, and it tells me the p-value of 0.0589. That gets split into left tail and right tail. In a two-sided test, the p-value appears on both the left-hand side and the right-hand side, and the p-value that's given is the total for both the left and the right tail. Anyways, how far away is that 179.6? Is it considered really far away or is it not? Well, we have, my shading doesn't really look very accurate here, but this is about 3%, and this over here is about 3%. So that adds up to about 6%, 0.0589. That is not, even though it's close to 5%, that normal cutoff that we usually use in stats, but it's a little bit higher. Okay, so it's not considered unusual. It's very close, but it's technically not considered unusual using the 0.05 as a gauge. All right, once again, we start with assuming the null is true, assuming that this company is filling up to an average of 180 milliliters every single bottle. We have about a 5 or 6% chance of getting a sample of, I don't know why I said 40 bottles, that should say 100 bottles, my bad. 100, typo, bottles with less than 179.6, that represents this tail, or greater than 180.4, that's this tail. This is not considered unusual, even though it's really close to 5%. So we are not considering it unlikely or unusual. We do not have evidence against the null hypothesis. Okay, let me zoom out so that I can kind of recap the three important things that we discussed, and I'm going to look at all three of these together. What is similar about all of these problems? Hopefully you're noticing that the null hypothesis, the H sub 0 or the H naught, those are all equations, and those are using the numbers in the problem that we are assuming to be true. Okay, so you find something as a baseline that we're using right at the beginning of the problem. We assume this, or we are told this, or in previous studies we have this number. Then you have a statistic. Okay, the statistic you'll be asked about. In this case, it was a p-hat. In this case, it was a p-hat. In this case, it was an x-bar. And we're trying to decide how far away is that statistic from our assumption. If it's really far away, that gives us a really small p-value, like this one. Okay, the 48% was so far away from the 37 because it was only a 1% shaded area over here. That gave me evidence to think, we have evidence that this number is not the real number anymore. And this was about the parking satisfaction, okay? We have evidence against it, okay? This number, the 18, was actually not very far away from the 22, not considered unusually far or alarming or anything like that based on the 24% that we were given. Therefore, that did not tell us anything against this null hypothesis. And same thing down here, we were assuming 180. Yeah, every once in a while you take a sample that might be a little shy. Sometimes you might take a sample that might have a little bit too much in it, but based on the percentages that we were given, and this one is a two-sided, so be careful about that. We split the p-value into half, and then each half was represented on each tail. This 179.6 was not that far away from the 180 there, even though it was close to 5%, it was a little bit higher, and we do use 5% as our cutoff usually. Therefore, that does not give us evidence against this number. Okay. Couple other things that are similar about these. Hopefully you're kind of understanding and recognizing that the interpretation of the p-value, this sentence that you have to write, it's kind of a fill-in-the-blank sentence. That's an important one. You will be asked about that to interpret the p-value. And the other thing is, in our alternate hypothesis for each of these, we did not have an equal sign. We had either a less than, because it said fewer, a greater than because it said improve, or a not equal because I didn't know which one to use, less or right. And this not equal one gets a little bit crazy because we have a little bit of different math to do when we're talking about our p-value, okay? So lots of vocab words that we've talked about so far. I am going to expand upon this idea tomorrow when I see you, and we're going to start practicing some FRQs, and we have a lot more vocabulary to memorize. But what I want you to be comfortable with is these things called the null hypothesis, the alternate hypothesis, the parameter, the statistic, and the p-value and how it relates to the bell curve. Okay, the interpretation of the p-value is something that you need to be very familiar with also. A one-sided test, I guess I should breeze over that one. Again, just to recap, that's because we only shaded one direction here. This one was one-sided because we only shaded one direction here. This one is a two-sided test, which impacts some of the shading over here. It goes on both sides. So that's another kind of vocab word thing that you had written down in your reading guide, okay? I'm going to pick up here tomorrow, and we're also going to get into 9.2 tomorrow, so please fill out your reading guide before you come to class, okay? Thanks so much. If you guys have any questions, need anything, have any concerns, whatever, just shoot me an email. I'm around, okay? Love you guys.